Okay, so first is the whole angle and then straight angle and then right angle, and then with that reference to all these three angles, we introduce other angles, right? Like obtuse, acute, and reflex also, right? Okay. Okay. So today we are going for another topic which is called measuring angles. So now only we are going to help the children to measure angles. So till now, did we introduce the children how to measure the angles? We introduced the types of angles, everything, right? But we didn't show the parts of the angles also, the children know, right? But we didn't introduce how to measure angles exactly. So that is what we are going to help them, right? Okay. So for that, we need fraction inserts, right? The circle from pole insert till cut 10th insert, right? Starting from pole to 10th. We don't have space. Yeah, measuring angles. This comes under angles 2. Already we dealt with angles 1, right? There we had some presentations. So today this is angles 2 topic. This is another new chapter, angles 2, which is measuring angles. Okay, under that, write it, measuring angles dash the Montessori protractor. So we are going to help the children to measure angles using Montessori protractor. Okay. Yeah. So this is how you need to introduce. You need to arrange all the inserts. For this, we need all the fraction circle inserts. Okay, right from pole to 10th divided by 10. All the 10 inserts you need, and we need a Montessori protractor. This is a Montessori protractor. I'll just explain you. Okay, so this may be, this is in green color now, right? The outer frame. So this you can see in some of the environment, this will be in black color, right? Okay, so these are the variations. So let us discuss what is there in the protractor. So can you see? What do you see? Yeah.
Circle.
Circle. Okay, first of all, you can observe the protractor is in the circle shape, but whatever the protractor we use, regular protractor, it will be in semicircle.
Semicircle.
Okay, so okay, then we should have some reason for it to be a circle, right? We'll discuss that. Okay, then so this is the frame. The frame is in the square shape, right? And then you can see a recessed circle inside the square. Okay, the circle here, the 0 marking starts. Okay, and then you can see the numbers growing 0, 10, 20, 30, like that. It goes on till 350, 340, 340, 350, and 360 aligns back to 0. Right? So these are all the markings we have here. Okay, and we can see different lines, different length of lines we have. Okay, so in all these numbers, okay, the markings 0, 10, every 10 markings, okay, the every 10 demarcations will be represented by a long line, you can say, not very long. Okay, when compared to other lines, it is somewhat long. Okay, every 10th marking, right, along with the numbers. And in between the 10 markings, you can see fifth, at every fifth demarcation, you have a little smaller line. Okay, little shorter line than the every 10th line. Okay. And so like that, every fifth marking also, we have separate lines. Okay. And for every single marking, okay, every single demarcation, or you can say every single degree, you have very small little marking. Okay, very short. It is very short markings you can see for every single degree, right? And you can see the angles grow from 0, and when it goes back to 360, it aligns the same. 0 and 360 is the same, right? Okay. Any doubts here? Outside? Let's go inside the circle. So inside the circle, can you see a line here? Vertical line over here? Okay. And you can see it starts from the center of the circle. This vertical line starts from the center of the circle. Okay. So this center of the circle, we call it as origin. Okay. And then this vertical line exactly points to which degree? 0 or 360, right? That vertical line, you can call it as baseline or zero line, whatever it is. Or even you can call it a side also. Okay. Zero line, baseline or side, whatever it is, you can call it. Okay. Is it clear? The Montessori protractor? Yes? Okay. Shall we start? Okay. Now, we have to let's align it this way for them. Okay, so this is how you need to arrange the inserts. Will you be able to see?
You have to lift the laptop slightly.
Oh no, when you lift it,
Higher.
higher. Here?
That's better, but we can't see the full table.
They can't see the full picture, right? Adya, move that, this insert there. Hamita, move it. Here. Avladhan, ippodiki, first time ஒரு தடவை காமிச்சிரலாம். Okay, so this is how you need to arrange it. I'll show you. Okay, so all the 10 inserts. Sure. Thank you. I think it's clear now, right? Okay, all the 10 inserts, you have to arrange it this way only. Okay, starting from hole. As we don't have enough space here, we arrange it this way, but it has to align exactly. Okay, hole, 2, and on this side, on your which side for you? This for them it is left side. Okay, and then in the horizontal line, you should have 3, 4, 5, 6, 7, 8, and down again to your right side, we should have 9 and 10. Got it? So this is the way you arrange every time. Got it? So in between, you're going to keep your Montessori protractor. Got it? Okay.
Sorry, ma'am.
Yes.
For online students, are we sitting at adults position now?
No, you are in the children position.
Okay.
Okay? Yeah. So now I'm just rearranging because we don't have enough space. Let's bring it down. Bring that down. Okay. Now, let's start it. So write the material description, everything, right? Okay. Under that, your first presentation will be story and presentation of the material. So you know, in Montessori, we introduce everything through stories, right? Okay. Story and presentation of the material. Okay, you need protractor and then inserts of the fraction parts of the circle, pencil tray, mat, everything. Okay, the purpose to help the child to measure different angles. This measuring angle is used to measure right angles and tell us about acute and obtuse angle. But with this protractor, actually, we were using the right angle to tell whether it is to identify whether an angle is an obtuse or acute angle, right? We were using the right angle, right, as a reference point to measure other angles, like it may be straight angle or your obtuse or acute angle, right? So the measuring angle was used to measure right angles and tell us about acute and obtuse angles. But now, with this protractor, we can measure precisely. So, prerequisites.
We can measure the sides, is it?
Measure the angles down, right? Angles precisely. Prerequisite. What would be the prerequisites? Can you think of? Angles? Huh? Parts of the angle they should know, right? Obviously, parts of the angle. Then types of angles also, right? Okay. Not exactly the types of angles, whatever you introduce, right, with the stick box, not necessary. But for that itself, if you think the children are ready, you can give it. But ideally, you have to give it after that. But before that also, the children, they know all the angles, right? Through your geometry cabinet itself, we would be introducing all those angles, right? Okay, you're using in a sensorial way, we were introducing it. You remember the obtuse angle, which is blunt, and which is pointed, you call it as acute angle. So like that we were introducing, right? So after that also you can introduce. Okay, and obviously they should know the fraction name of the fraction pieces, right? So in arithmetic, we'll be doing that. Okay, so this presentation comes after that. The children, they should know the names of fraction pieces also, right? Shall we start? Yes? Okay. So this presentation is a small group presentation. This starts with the story. Would you like to write the story? Right? Okay. It's a small one here. It's very small. We can write it. Okay? Yeah. If you want to write down, you can write it. Okay. So today we are going to see how to measure angles. When we work with angles, we use different forms of measurement, which is very, very old. Do you remember Babylonians? They were interested in many things. The Babylonians, they were interested in many things. One of the things they were interested in was the study of stars. They were excellent stargazers. Also, they were very good at measuring, and kept records of everything. In the form of pictography. What do you mean by pictography? Representation by pictures. So they were interested in recording everything, and they were recording in the form of pictures, right? Okay. They watched the stars every night. And they discovered that when they watched a particular star, it was at different positions at every night. A particular star, it was at different positions every night. So they observed in the night sky. So they observed the particular star every night. And what did they do? You know, they mark, right? They mark the position of the star where it was. Okay, so every night they observed the particular star and they kept on marking the position of the star every night until it returned back to the original position where it started. Right? Until it returned back to the original position where it started. Then they noticed an interesting thing. The star made a particular path. It had a circular orbit. It had a circular orbit going all the way around from where it started. Going all the way around where it started. And it is where we get the idea of circle form. Okay. And it is where we get the idea of circle from. Okay. Circle from. We get the idea of circle from that markings. So they ended up marking 360 marks. They ended up marking 360 marks and concluded that the star must have gone around a circle. And concluded that the star must have gone around a circle. And Babylonians, they used their observation of the star to make calendar also.
Ma'am, please repeat last sentence.
Yes, the Babylonians, they used their observation on the stars, this observation, right, on the star to make calendars. Their calendar at that time, it had 360 days. Now you know why did they have 360, right? 360. Their calendar had 360 days. But considering it was very long ago, right? Long ago, but it was quite accurate calendar when compared to our calendar now, right? It was accurate at that time, right? How many days do we have now? 365, right? We have 365 days, but they had 360. It's quite accurate, right? At that time, because it is very long back. Somebody has to mute, I think.
Neha, please mute.
Sorry.
So the total journey of that star was made up of the total journey of the star was made up of how many markings? 360 markings, right? So they divided the circle into 360 parts. See? What is this? So whole circle. Okay, if we take the whole circle insert, we can divide this also into 360 parts we can divide. Okay, we can divide this whole circle into 360 parts. But we have a special instrument. To measure this 360 divisions. Okay, which is called protractor. This is called protractor. So this is a special instrument to measure 360 divisions. Okay, so this is called protractor. Okay, so after giving this story, you can ask the children to bring all the fraction inserts and ask them to arrange it. Already the children, they know the arrangement, right? Already the children, they know the arrangement of the fraction insert. Okay, ask them to bring all the 10 inserts and ask them to arrange it after the story. Okay, now we can take any one, would you like to take? Yeah, take any one, choose any one fraction insert. Any one insert. Choose any one insert. Yeah. You remember the parts of an angle? You remember? So what are they? Parts of an angle. Sides. These are the sides, right? Okay. Shall we place the label for that? Sides. So these two lines are called sides. Okay. And then starting from this bottom. So this. So this is called vertex. The point where two sides meet, we'll call it as vertex. Right? Okay. And the measure between the two lines are two sides at the opening. Okay. So the measure between the two sides at the opening, we call it as angle. Yes. What is angle? Okay. So now, yes. So these are the parts of an angle for this fraction insert. Anu, do you think will it be different for all the other angles also, or other angles also have all these three parts? All angles have the same parts, right? Okay. But how are they different? In the angles, right? Or the amplitude. Angle or the amplitude, they are different, right? Okay. Now, so let's measure these angles using this Montessori. So this is called Montessori protractor. Okay. So we use this to measure angles. The name protractor comes from two Latin words. Pro means forward. Pro means forward. Track means to trace. So what is the literal meaning? Forward tracing or tracing in a forward direction, right? Okay. Okay, now as we discussed earlier, right? So like that, you can discuss all the things about the protractor with the children. Okay, I'll let them observe the protractor, and then they can tell their observation about the protractor. So you can go on discussing about the parts of the protractor. Okay, yeah. Pamita, what it is made up of, this protractor? Just observe the protractor. It is made up of angles. Okay, it starts from 0, and you can see growing. Okay, and you can see divisions, right? Small divisions, and it grows till 360. Okay, 360, and again it comes back to 0. 360 and 0 are the same here, right? Okay, and so this protractor starts from 0, and it goes all the way and comes back to 0. So here you have 360. So this circle, we can say this whole protractor is divided into 360 equal parts. This protractor is divided into 360 equal parts. We can count it in tens, right? Now you can ask the children to count 0, 10, 20, 30. So like that, go on counting one by one till 360. Okay. And we can have, we have this lines, this black lines, right? The small black lines. Okay, which the This lines with the degree, they represent for every 10 steps, right? Every 10 steps, we have a little longer line. And then the medium line we have, right? So that is for every 5 steps. So this small lines, they count up to 5. And we have tiny lines we have, right? So that represent for each step of the star, right? So because these are the steps taken by the star, right? So, and here inside the circle, you can see a line here. So the starting point of the line, the center, it is called the center of the circle, which is called origin. And this line starts from the origin, it goes towards it points towards 0, right? So this is called 0 line or baseline. Okay. How does it look like? Clock? Okay, yeah. Clock. It looks like a clock or a no. Yeah, anybody else?
Sun.
Sun? It looks like a sun. Okay, sun rays. Okay, the angles are sun rays. And then? Anybody else? Does it look like a scale? You were about to say? Yeah. Let's say it is bending scale. So it looks like a bending scale, right? Okay. The children may say something. Anything, okay? Just accept it. Okay. So now let's measure any angle, right? Okay. Let's choose any one angle. I have chosen any one insert. You can choose. You can ask the children to choose any one insert. Okay. And now we are going to show them how to place the insert inside the protractor. Okay. We know the parts of angle, right? So these are the sides. Okay. Now, how many sides do we have in an angle? 2 sides, right? So one angle, remember when you're placing the angle into the protractor, okay, one of the side, it has to be aligned to the baseline. And your vertex has to coincide with the origin of the protractor. Your vertex of the angle should coincide with the origin of the protractor, and your one of the side of the angle should coincide or should align with the baseline of the protractor. Let's place it. This is how you need to place. Now, for you to measure, for measuring angles, you need to look at the other side, where exactly it is. Look at the other side of the angle, where exactly it is. How much degree shows, Anu? How much? 70 degrees. So, 70 degrees more on the other side. Okay. So, now we can say this angle measures exactly 70 degrees. I'll show you how to write it. 70 degrees. Okay. What do you mean by degree? Okay. When we measure angles in parts, we call each part as degree. Okay. When we measure angles in parts, we call each part as degree. This comes from 2 Latin words, degree. D means 1. Gree means step, which means a step or 1 step. Okay. That step like the steps took by the star in the sky. When they go around, right? Okay. So when we want to write the degree, okay, write. So how much is the measurement? 70. So write 70. And when you want to write degree, you make a tiny little circle above the measurement, above the number. Tiny little circle above the number to show the circle path made by the star, right? So write the degree and place it. Amita, would you like to measure any other angle by yourself? Yes, come. Yeah, replace it and then choose any other. She has chosen third. So you coincide the origin with the vertex, right? What is the other rule? You have to coincide. One of the side has to be aligned with the baseline alignment. One of the side has to be aligned with the baseline. Now, so for you to for looking at the measurement, look at the other side.
Other side. 120 degrees.
120 degrees. Okay, would you like to write it? 120 degrees. So like that, you can ask the children to measure other angles, right? 120 degrees. Okay. So any doubts here in this presentation? Any doubts? Clear? Clear? Okay. Now, what could be the
Ma'am,
follow?
this can be done after the parts of the fraction inserts are introduced, right? We don't have to
not
work.
parts. Yeah, after the names of the fraction inserts. We'll be doing that in arithmetic. Okay. So after that and after they know about the parts of an angle, you can introduce it very well. Right? Okay. And what could be the follow-up activities?
This one has to be in the line.
That you have to align from the mat. Don't take it. Right? Okay. So what could be the follow-up activities after this? They can measure other angles also. And then
They can also draw it, no?
they can also draw. How do they draw?
With the fraction.
With the fraction
Fraction
insert. So you can ask the children to choose any one fraction insert, ask them to trace it on paper, right? And then they can color also. They can color that and whatever the measurement they have taken, they can write it. So like that, as you said, they can trace it and do. Okay. And one thing is you can completely trace the fraction insert and you can color and do. And other thing, how many corners do we have? Actually, three corners. So they can mark, keep the triangle, keep the fraction insert on the paper, mark these three corners, right? And using the scale, join them together. So what do you get? You get a triangle, right? You get a triangle. So when you get a triangle, how many angles do we have? 3. So those 3 angles, they can measure it with this, right? Got it?
Yes.
But with this fraction insert, you have a curvy line here, right? So you can't measure these 2 angles because it should have some straight lines, right? So only one angle you can measure. But when you mark these 3 points and join them together, and with that you can cut and measure it with this protractor, right? And you can measure all those 3 angles.
If you place here, they are asking us. This arm is placed.
What is the etymology of protractor? See, they are placing it on the opposite side. Okay, they just align the other side of the fraction insert to the baseline, and they are looking at this angle. Okay, what is the
Facing
in forward direction, right? And also you are placing it in the other way around. Got it? So you should place it this way only. Correct?
If we cut that shape, how can we measure, ma'am? How, if it is straight lines, can we measure with this?
That will come back, Ram. So this is the introduction. So you are always leading to the next presentation. We'll do it. Okay. Now this is just to give them how to measure angles and give them the idea about how the idea about angles came and how the how this idea about circle came. Okay, connecting with the story, right? So this is the introduction. We'll do that.
So we can leave children to basic and the practice and protector and the measure the
Where the protractor? Okay, keep it in the protractor. This Montessori protractor, and they can measure 3 angles there. Okay, and what else they can? They can take insert from the geometry cabinet. That also they can trace. So they have other quadrilaterals, polygons, everything they have, right? They have measured. They can measure other angles also. Okay. So basically, okay, any figures which have straight lines, you can measure angles, right? That is the idea you are giving to the children. Yeah. Clear? Clear? Shall we go to the next one? And always, and one more thing, you always remember, what is the definition for angle? What do you mean by angle? Point. Is it a point? The measure between two
Open.
Sides.
at the opening. Okay, so that is your interior angle. Don't look at the exterior angle. When you were practicing, I saw many of you, you were looking at the other angle. Okay, that is the exterior angle. Don't look at that. So that is what the definition clearly says, that the measurement between the two sides at the opening, not at this side, back side, right? Okay. So let's go to the next presentation. Second one, addition of angles with Montessori protractor. So obviously, this has to be given after the introduction to the Montessori protractor. Purpose is to add angles. Okay. So, I need one child. Wants to come? Yeah, come. Please come. No, come. Always sitting in front, they are coming. Come. Come. Okay, yeah. So let's do this presentation. The same arrangement, okay? The same thing. You need a check paper. Today we are going to add angles. Choose any two fraction inserts, ma. Choose any two fraction inserts. Any two. She has chosen 10th and 6th. She has chosen 1/10 and 1/6. She has chosen 2. Okay. Now, write it in the paper. Measure of the first angle. I have written already. I'll show you. Measure of the first angle. Measure the first angle and say how much it is. How much it is? 40 degrees. Okay, write it. Write it next to the equal to 40 degrees. 40 degrees down. Is it true? 40 down. 40 down. Then 10 dane. 360. 36. 36. 36. 36. Okay, measure of the first angle 36 degrees. Okay, now measure the second angle. Take it out and measure the second angle. Measure of second angle. What is it? 60 degrees. Measure of the second angle 60 degrees. Now, sum of the angles equal to how, what do you mean by sum? How do we do? Add. Put them together, right? Just join them together and see how much it is. Not on the paper. 96. So she kept the first angle, okay, and then the second angle. We can. Okay. Both are same, but okay. So put them together and see where these two, the side of the second angle, the second side of the second angle ends. It is 96.
If you show them 36 plus 16.
Why? No need. Correct? So this is how you need to add the angles. So these two angles together measure 96 degrees. Right? This is the sum of angles. Would you like to add more angles? The children, they can do. Clear? Yes? Okay. So what could be the follow-up activities? What could be the follow-up activities?
Make as many
Try with-
combinations for addition.
They can choose other angles for addition. Okay. And then you
They can choose with more than 2 pieces also, no?
more than two?
Fraction pieces.
Yeah, they can use more than 2 fraction inserts. Yes. Yeah. Because this is the technique we have given them. So the children, they can extend their work. And then what else can you think of?
Measure the angle of the clock.
Sorry. Yeah. Yes, you were saying something?
Clock angles, time
Time?
angles in the clocks basically. They can add like 3 o'clock, 6 o'clock. What will be the total angle?
Yeah. Okay. But
We
only the hours we can add, Ajay. When it is on the hour, then only we can add, right? Yeah, by this technique, right? Okay. And what else? You can even you can ask them the leading questions like how many angles do you need to make a straight angle?
How many right angles do you need?
How many? Sorry. Exactly. Then you want to ask exactly. Okay.
Yeah, because do decomposition of one angle.
One angle. Okay. So how many right angles you need to make a straight angle? Right.
In all the combinations they do, how many are acute, how many are
That's
obtuse?
only one combination is possible, right, Asha? With the right angles.
But for
Okay.
acute, obtuse, because they know it.
Then the combinations will vary. Right. Okay. So here itself they can try to make only straight angles. Using different inserts, they can make straight angles. So what are the combinations are possible? Yes, Suji. Yes, obviously. When they know the types of angles, we can ask them to identify the angles also, right? You can give a specific angle and ask them to make it use the protractor by combination of angles. Like reflex angles, you can ask them, right? Would you like to make reflex angle, Samita? Would you like to make reflex angle?
You can like straight angle, you can make right angles. Two
Yes.
angles.
To make right angles. Straight angles. No, that's it.
More than
More than 180. Two angles you need. First place any one angle. This side. Okay. Now choose another insert so that it makes you more than 180. Correct? So like this, you can ask the children to give some command cards for them to make combinations, right? Okay. Let's go to the next one. The same thing, subtraction. Subtraction of angles using Montessori protractor. Anybody wants to come? Anybody else? Subtraction of all angles with Montessori protractor. The same thing. Okay. Choose any two angles to subtract. Okay. She has taken 5th and 9th. Okay. Yeah. Now let's measure the which is the bigger angle. Let's take it as a first angle, right? Because minuend has to be bigger, right? Okay. So this is the minuend, right? So what is the measure of the first angle? 72. 72. 72. Okay, 72. 5th only, right? 72. Okay, 72 degrees. Measure of the first angle is equal to 72 degrees. Okay, let's measure the second angle. What is the measure of second angle? How much it is? 9, 40. 40 degrees. That is the measure of second angle. So now we are going to subtract the second angle from the first angle, right? Okay. So now what we have to do? What was the first angle actually? No, wait. 72. Okay. Now you need to align the first side of this angle, second angle. Okay. This is the second angle. The first side of the second angle has to be aligned to 72 degrees because we need to give away from 72, right? Okay. In such a way, you have to place it. 72 it was, right? Okay. So this side, the second side, okay. This second side has to be aligned with 72.
Second side of second angle.
Second side, correct. Second side of the second angle has to be aligned to the first angle. Whatever you measure, right? Because what is the logic actually? You're going to give away this angle from this angle. Correct? Okay. So whatever is left now, that is the subtraction of angle. What is left? 32. 32 degrees. That is the difference of the angles. Here. So here you're not going to use, see, first of all, you're going to measure the two angles separately and then placing the second angle, okay, exactly in the measurement of the first angle. So that you get whatever left over, that is your difference between the angles. Got it? Because whatever you have, other than you can give away, right? Okay. So now the children, they can try with the other angles and find the difference of the angles, right? Clear? Would you like to do one more, or is it clear? Yes.
We'll do one.
Anybody wants to do one more?
And one more.
One more. Okay, fine. Let's choose. Which insert you want to choose? You tell me the insert. We'll choose it here. Which one? Yes.
1/10.
1/10. Okay, 1/10 we have chosen, and what else?
1/3.
1/3. Choose 1/3. Okay. Just measure the first angle. (120), right? 120 degrees. The first angle is 120 degrees. Okay. Now measure the second angle. How much it is? 36. Measure of the second angle is 36 degrees. So now she is going to subtract the second angle from the first angle. First angle was 120. So 120, you have to place it
One side,
The second side.
second side of the second.
Second angle aligning to 120. See? Got it? Okay. Whatever left, that is your difference. How much it is? 96.
94 or 96. 84. 84.
Oh,
That's more. 120 minus.
Ama.
84.
How much it was? 36. இது எவ்வளவு இருக்கு? 120 தானா? 120.
120.
How much it is? 84.
84.
84. Correct.
3.
Got it? 84. So this is your subtraction of angles. So what could be the follow-up activities? As we discussed in the addition, the same thing they can do, right? You can give them some different angles, reflex angle, straight angle. So like that you can give them and they can make it. You can even ask leading questions like, what happens if we subtract right angle from straight angle? Another right angle. So like that you can ask from leading questions. So the same subtraction or addition, they can do it with the square inserts also. This we have, we did with the circle inserts, right? The same thing, we have square inserts, right? The square divided squares we have, small metal inserts. That they can try it here, right? Okay. Let's go to the next one. Further exploration with angles. Further exploration with angles. Further exploration with angles. Under that, multiplication of angles with Montessori protractor. So let's go fast. The same thing only. So you can now tell me the presentation, how it has to go. Multiplication. What do you mean by multiplication?
Repeated addition.
Repeated addition. They have to take from the same fraction, ma'am.
Take yes, multiplier times. Okay, choose a multiplier. Choose it multiplier times. Try it.
Choose one.
But from that insert only you have to take that many times. So she has chosen sixth. So it is 60 degrees. So write it. Measure of the angle. Measure of the angle 60 degrees. So second line, number of times taken. Let's take 3 times. Number of times taken. So look at this. 3 times. Number of times taken 3 times. Now put a multiplication sign also. Okay, this side multiplication sign. 3 times we have taken. Okay, ma? So let's take 3 times. Quickly. How much it is? Okay, we got how much it is? 180 degrees. Right, 180 degrees. That is the product of angles. Product of angles is equal to 180 degrees. Got it? Okay, here also same follow-up activities. Okay. So like leading, what could be the leading questions? Anybody?
And you make straight angles with can you make right angles?
How many right angles you need to make a straight angle? How many straight angles you need to make a whole angle? Right? So like that you can ask. Okay. So they can try with the square inserts also. So what would be the last one? Last presentation?
Division.
What do you mean by division?
Sharing equally.
Sharing equally. Okay. So the division of angles with Montessori protractor. Should I name? Shall I start? Yes? Okay. So let's choose the second insert. The second one. Okay. So today we are going to divide angles. Okay. Let's choose one angle. So I assume I have taken a straight angle. Okay. I have taken it from half. Okay. Let's measure this angle. So now we are going to measure this angle. So now we are going to divide this angle by 3. So let's measure this angle. We are going to divide this angle, this straight angle by 3. Okay. So she has measured the angle. So measure of the angle to be divided is equal to 180 degrees. Measure of the angle to be divided is equal to 180 degrees. Yeah. அப்படியே வராது 120 தான வரும் 18 எப்படி வருமா வராது எப்படி வரும் எனக்கு 180 வராது இந்த காம்பினேஷன் இல்ல. Okay, so now we are going to divide number of times the number that divided is 3. Write it. That is the second statement. Number that divided. Number that divided is equal to 3. So now we are going to divide this half insert into 3 equally, right? Can you find out any 3 small fraction which made to this half fraction? Take. Let's take it out. So she is choosing from 6th, 1/6, and she made it to 180 degrees. Yes, it fits, right? It fits exactly, right? Okay, so now we divided this straight angle into 3 angles, right? So what is the answer for division or quotient? One share. The measure of one share. What is the measure of one share here? 60. Let's put it. So then we measure only one angle and see what is the quotient, right? Measure only one angle and see what is the measure. Take it out or else you can okay, 60. So write it. Measure of each angle is 60 degrees. That is the third statement. Measure of each angle is equal to 60 degrees.
They don't know how to, now we know that this will make a difference. They don't know how to do it. Superimpose.
Superimpose and see. Take this out, superimpose and see whether it makes or not. But by this time when they worked it, they know what are the combinations, the equivalent fractions and all they know. Right? Okay. Yes. Okay.
After fractions,
Yeah, so fractions also it's going parallelly in arithmetic, right? So they are working parallelly only, so they should know by this time. Otherwise, they can take it very well and they can superimpose and compare and see. Right? Okay. So follow-up activity is also the same thing. So what should be? So when dividing a straight angle by right angle, what do we get? Huh? When we divide a straight angle by right angles, what do we get?
Two right angles.
Is it quotient? 2. You are looking at the quotient now. Right? 2. 2 times you can divide, right? Or 2, you can divide into 2 equal parts. That is what you are looking at. I have an angle of 180 degrees. Leading questions only. So I have an angle of 180 degrees. And what I want to find is how many groups of 30 degrees are contained in 180 degrees. So like that you can ask some leading questions. Or how many degrees, how many groups of 60 degrees are contained in 180 degrees? Because we don't have 30 degree here, right? So how many degrees of, how many groups of 60 degrees are there in 180 degrees? Like that you can have some comment cards, leading questions you can ask, right? They can do the division of fraction inserts, square inserts also they can do. Got it? Any doubts still here? Do we have?
So how do we measure square inserts, man?
How do we measure? Yeah, how do we measure the square insert?
We'll place one side against the baseline and then zero.
It actually lies outside the circle, recess circle only, right? Or else if you want to cut it out, make some cutouts, trace it and cut it out, that also you can do. Right, Imtiaz? Got it?
Do we have any square insert in the center? Can we see?
Yeah, we have. Just kindly bring any one square insert, right? Okay. So, yeah, any other doubts? Okay. So this is how you need to place. It lies outside the frame only.
Okay.
But you can measure the angles. So which corner you want to, this corner only I want to measure. So that alone, I have to align it to the baseline and the origin. That's all. And
Okay.
measure
And
the
there'll
other
be
side.
real small ones also, no? Which will be
Small
inside
ones
the-
also. Small ones, the very small ones may fit. The 1/8 and all. But not all
Okay.
those things, right? She has brought the
Okay.
thick one, the big one. It lies actually
Oh.
outside. That is
Okay.
fine only. Right?
Okay.
Because you're not going to measure the area. You're going to measure the angles. Right? Okay. So let's go to the next one quickly. Introduction to the regular protractor. So now we are moving slowly towards the regular protractor, whatever we use. Right? Introduction to regular protractor. Under that, first presentation will be measuring angles. So here, I'm going to draw an angle and we are going to help the children how to measure the angle. Right? Okay. So take scale, pencil. So we have been using Montessori protractor for measuring angles, right? So till now we have been using Montessori protractor to measure angles. So but we can use this Montessori protractor only inside our environment, right? Outside the world, we cannot use it, right? We have other protractor to use for measuring angles. That is called protractor. But what is the difference you see from our Montessori protractor to this regular protractor? It has only straight angle. There we had whole angle, but we have only straight angle. But still we can measure all the angles with this. Let's see how it is. Okay. Now, so this is the regular protractor to measure angles. It is divided into how many parts? 180 equal parts. How it is made up of? It starts from 0, goes all the way to 180 degrees. And you can see 0 from the opposite side also, right? In the opposite side also 0, and it is going all the way to back to 180 degrees. That also you have in opposite side. So here also at every 10th mark, we have lines, right? 10, 0, 10, 20, 30. So like that, we have marks every 10. Okay. And we have small, we have every fifth also we have markings. But without numbers, we have markings for every fifth. And very small, tiny lines we have for 1 degree. Each degree we have. Here also, the same thing. And can you see the midpoint here? So this is the line 0. You can see a line here which connecting this 0 to this this 180, right? This line, it is called baseline. This one, this one is the baseline. This one is the baseline, and midpoint of the baseline is called as origin. Baseline or 0 line, and this is the midpoint. Okay, so how does it look like? That look like a bending scale. So this one, how does it look like?
Semicircle.
Half of the circle, first semicircle. Yes. Now let's draw an angle and measure it using this regular protractor. Draw any angle. Okay, for you to draw an angle, what you should do? First, draw one side. Draw one side of an angle, right? Any measurement. It can be any measurement. Draw one side of an angle and draw other side starting from the origin or vertex. Draw the other side. Starting from the vertex. So this is the, and you can even mark the vertex also with a little darker dot, right? Mark the vertex. Now, how to use this regular protractor? So this origin, the same thing. This origin has to be aligned with the vertex of the angle. And rotate the protractor so that the baseline is aligned with the one side of the angle. And you need to look at the other side where it lies. So whatever your angle says, okay, you have to start reading from 0. Okay, wherever your side ends, so there start looking from 0. 0, 10, 20, like that. Look at it. So I have 28. So I'm going to mark it 28 degrees. Right. Okay, so you need to align the origin of the protractor to the vertex of the angle, and so adjust the protractor such a way that your baseline aligned to the one side of the angle, and look at the other side. You are going to measure the other side of the angle. Okay, so you need to follow the measurements from starting from 0 and move upwards. Starting from 0, move upwards. So how many degrees it is? Measure it and mark it. So if you have drawn a small, small angle, if it is not going through the protractor, what you have to do? You have to extend the lines, right? Okay. So like that, the children, they can draw any angles and they can measure it, right? Any doubts here in measuring angles? Any doubts?
No, ma'am.
No? Okay. So this is how you need to measure angles. Okay, let's finish one more simple presentation. Creating angles, second one, creating angles of specific amplitude. Creating angles of specific amplitude. So now, so the first presentation was you have drawn any random angle. So you just draw a random angle and you were helping them to measure it. So here you're going to draw the angle, whatever it has given, you're going to draw that particular angle. You're going to measure and draw. Okay, so for that, you're going to use the scale and protractor the same way. Okay, first, draw a line. Okay, mark one end of the line with little darker dot to show the vertex. Right? Okay, now place the protractor aligning to the origin, to the vertex of the angle, right? Okay, and your baseline has to be, so rotate the protractor, adjust it so that your baseline has to be aligned with the one side, whatever the side we have drawn. Okay, align it exactly. And so now we are going to draw 68 degrees. Okay, let's try to draw 68 degrees using the regular protractor. So starting from 0, go upwards, right? 10, 20, 30, 40, 60, 61, 65 I have, 66, 67, 68. Mark a point at 68 degrees. Okay. Now join the vertex and the marking just now you made. Join them together. Now mark that angle, 68 degrees. Now we are showing the 90 degrees different angles. Earlier presentation itself we have written. Earlier also we marked the angles. We have written the angles, the inside angles, right? Okay. So we'll stop with this. Okay, we have one more presentation. This will continue in the next session. Okay, and 2 minutes. Okay, so we were discussing about the what was it? The relationship between quadrilaterals, right? The family tree of quadrilaterals, right? Did you go through with that? Any interesting thing did you find? Any of you? The family tree of quadrilaterals. You remember, we came from common quadrilateral and then what was the relationship? I'll show you the pictures.
Was the square.
Square, we ended up with square, right? You remember this? We placed the arrows also, the relationship, right? Did you find any interesting things in this? Anything? What did you find? That is what I'm asking. Huh? Did you find anything? So we started with common quadrilateral, right? So which is most irregular, right? Which is most irregular. And we are exactly opposite to that. We ended up with square, which is most regular. Right. Then what does it mean? What is it showing? And this side I have, okay, common quadrilateral. And this side we have trapezium, parallelogram and rectangle, and it became square, right? And this side, look at this side, right, rhombus and square this side. Now, one side we made the angle, right, change the angles, and the other side, the sides of the quadrilateral. Then
It's going from irregular to regular and then again.
Growing from irregular to regular, right? Then
So the other reverse way. Also,
you can in between also can you observe the steps actually? Common quadrilateral, which is yeah. From
This side.
how it is becoming, that is what I'm asking. How it is becoming, you can simply say it is becoming from irregular to regular, but how it is becoming actually?
The
Look at
sides, ma'am. parallel sides they have
Let's
and the
go.
angles.
Yes. So for that only you need to look at the sides, parallel sides and angles, right? Okay. Common quadrilateral, you don't have anything common, right? You don't have any specific properties, right? Which is most irregular. And when you come to trapezium, you had one pair of parallel sides. And then what happened when you come to parallelogram? Two pairs of parallel sides. And you can see even opposite angles are equal, right? Okay. When you come to rectangle, what happened? Two pairs, but all the
right angles.
Angles.
Right
same.
angles.
So it is in the process of becoming regular shape.
Regular.
Can you observe that? Right? When you look at the other side also, you can find the same pattern. So like that, you can ask the children to observe the pattern. Okay. And one more thing in the note, footnote only, I wanted you to write. Footnote, take the footnote of it. I wanted to add something there. Okay, now, and also I asked you some leading questions. You remember, can I call a kite a common quadrilateral?
Yes.
Can I call a kite a common quadrilateral? No? Yes, it is a common quadrilateral. Kite is a, but anything can be common quadrilateral, but I cannot call a common quadrilateral as a kite. So what does it mean? So in the hierarchy, look at the hierarchy. Okay. So any shape which is one step below in the hierarchy, I cannot call it with the previous one. Okay. But not vice versa. Right. So any shape in the lower hierarchy can be called with the name of higher hierarchy. Correct. So that can be your observation you can write. And so when you look at the square, how many generations it has gone by? You remember when we introduced the family tree, we talked about the, what did we start? How did we start actually? We talked about the ancestors, right? So how many generations the square has gone by? Huh? Fourth generation on this side and third on this side. Correct? Okay, just look at the square. How many generations it has gone by? Fourth on this side and third on this side. So like that, you can look at for any, when you take the parallelogram. Two on this side, 1, 2 and 3 on this side. Again, this both are related, right? So like that, you can look at for any shape. How many generations you can, it has gone by, right? Got it? So this thing, write it in the footnote. So any doubts? Let's close it. It's time already. Yeah. 1:15, right? 1